You know, it's kind of wild to think about, but before the 20th century, a simple scratch could actually kill you. Seriously, a sore throat, a cut on your hand, an infected tooth, any of those could easily become a death sentence. But then, one discovery came along and changed everything. It basically turned death itself into a treatable condition.
And that's what we're talking about today, the story of that miracle drug, the one that really built the modern world as we know it, antibiotics.
So to really get just how huge this was, we got to go back. We have to picture what the world was like before this miracle existed. And honestly, it was a world of constant, terrifying infection.
I mean, the reality before antibiotics, it was just brutal. Get this, infections caused somewhere between 30 and 40% of all deaths. Just let that sink in for a second. Surgery of any kind, a total roll of the dice, mostly because of the infection you'd probably get afterwards. Childbirth was one of the most dangerous things a woman could do. And yeah, things we barely even worry about today, pneumonia, strep throat, they were massive killers. That was just normal life.
But that whole reality was about to be completely shattered. And not because of some grand, brilliant plan. Nope. It all came down to a messy lab and a moment of pure accidental genius.
So the story goes, it's 1928, and this Scottish physician, Alexander Fleming, he gets back to his lab in London from vacation. And he finds something, well, odd. One of his petri dishes, you know, the ones that are supposed to be covered in bacteria, it has this patch of mold growing on it. But here's the crazy part. All around the mold, there was this clear circle, a total kill zone where no bacteria could grow. He knew right away he'd stumbled onto something huge. He named the substance penicillin, and just like that, a miracle was born from a total accident.
Okay, so what exactly did Fleming find? This is the crucial part. He discovered the first true antibiotic, and that means it's a substance that can kill the bad stuff, the harmful bacteria, while leaving our own human cells totally unharmed. That was the secret sauce. It was like a smart bomb, a targeted weapon nobody had even dreamed of before.
All right, so how do these microscopic weapons actually work? I mean, how do they pull off this amazing trick of killing the invaders but leaving us perfectly fine?
Well, you can think of them like these tiny, precision-guided missiles. Each one is designed to mess with bacteria in a really specific way. Some of them go right for the cell wall and just tear it apart. Others stop the bacteria from reproducing by jamming up their DNA. And then you have others that shut down the little factories that bacteria use to make proteins. It's a full-on assault.
Let's zoom in on penicillin, specifically. Its secret weapon is this chemical structure called a beta-lactam ring. And what it does is it attaches itself to the exact enzymes a bacterium needs to build its protective cell wall. So by blocking those enzymes, penicillin makes it impossible for the bacterium to build or repair its wall. And what happens? The wall gets weak and pop. The whole thing just bursts.
Here's a simple way to think about it. For a bacterium, getting hit with penicillin is like someone coming along and removing all the bolts that hold a machine together. The whole structure just fails. It falls apart and disintegrates. It's just an incredibly clever and effective way to take them down.
So Fleming's discovery was the spark, right? But turning this little lab curiosity into a global lifesaver, that was a whole different story. It was a massive effort, and it kicked off a true medical revolution.
Just take a look at this comparison. I mean, it's night and day. Before antibiotics, infections were at top killer. After, survival rates just shot through the roof. Think about it. Complex surgeries, organ transplants, even intensive care. None of that would be possible without a way to control infection. So yeah, antibiotics didn't just cure a few diseases. They literally made modern medicine possible.
And this wasn't a one-man show. This timeline really shows how it took a village to turn that discovery into a real drug. So Fleming made the initial find, sure, but it was a team at Oxford led by Howard Florey and Ernst Chain who figured out how to purify it and prove it actually worked in people. And then, during World War II, U.S. companies developed ways to mass produce it, finally making enough to save countless soldiers, and then the world.
And the result of all that work? Well, it's estimated that penicillin, by itself, has saved over 500 million lives. Just wow, that is a staggering number. It's easily one of the greatest medical breakthroughs in all of human history.
But here's the twist in the story. There's a dark side to this miracle. Because bacteria, they fight back. And that brings us to the crisis we're facing right now. What happens when the miracle drug stops working?
What's incredible is that Fleming himself saw this coming.
Way back in 1945, in his Nobel Prize speech, he warned that if people misused penicillin, they could basically teach microbes how to resist it. And boy, was he right.
And for decades, that's exactly what we've done. Misuse and overuse both in medicine and in farming have done exactly what Fleming was afraid of. They've sped up the evolution of what we now call superbugs. These are bacteria that can just shrug off our best drugs, turning infections that were once easy to treat back into deadly threats. The scary part, without new solutions, we could actually go back to a world where a simple cut could kill you.
But listen, the battle is not over. Just like scientists rose to the challenge back in the 1940s, a whole new generation is now creating the next arsenal of weapons to keep fighting infection.
And what an arsenal it is! I mean, scientists are exploring some really futuristic stuff. We're talking about things like phage therapy, which basically uses viruses as assassins to hunt down bacteria. There are CRISPR-based tools that can go in and surgically destroy a bacteria's DNA, and even treatments that are personalized to your own unique gut bacteria. The fight is continuing on some really exciting new fronts.
So when you look at the whole story, from a complete accident in a messy lab to a global lifesaver and now to a global crisis, it's just this powerful reminder that the epic battle between us and microbes, it is far from over. It's really a race between our brains and their ability to evolve, and that leaves us with one big question. What will the next miracle be?